And howdy y'all, welcome to a video helping out with lesson 4-7, one-step equations, you guessed it, with integers. I believe we have already gone through these answers. If you need, and if you just want a little extra review on assignment number 33, pause now, come on back when you're ready. Why does it seem obvious? Well, we've been working all the last week and a half even, on how to compute integers. That would be add and subtract and multiply and divide. And so naturally, we want to see how that works with equations and algebra. We're going to still use our integer skills. We're going to still use our integer skills solving one-step equations for now, but you know what's coming. Eventually, we'll be moving into two-step equations. Let's just pause for a moment, and I want you to think, okay, how do you get rid of +5? So we have some missing number, a money bag full of money. You guys love my art. I know it's terrible. Money bag full of money, $5. You can see it down here. But really all we want, using a little bit of disappearing ink here, we just want to know what x equals. And of course, we can't just take away 5 and make the equation unbalanced. So one way we talked about this is to add the opposite. In other words, a +5 and a -5 will cancel out, making 0. But that's not fair. Hold on. Let's go ahead and add the opposite to both sides. Now, in this case, +5 and -5 will cancel out. Oh, good. It says x by itself and alone. That is what we wanted. Meanwhile, if we had 11 and we add a -5 to that, you'll see those 0 pairs canceling out. And it sure appears to be that x is 6. Now this is the visual, and I've been pushing you guys quite a bit on being able to draw it. Let me show you side by side right next to it how to write it, not how to solve it, not with visuals, but with numbers, symbols, and algebra. So what we would do to both sides is add a -5. And as I've been working with some of you to make sure you're doing this, +5 and -5 will cancel out, making 0. And of course, you don't have to write x plus 0. Meanwhile, we have 11 and a -5, which put together make a +6. So now you can see visually how to solve it by getting rid of a +5 with a -5 and watching it cancel out, as long as you're fair to both sides. And you can see algebraically using numbers and symbols. Add a -5 to both sides. 5 and -5 cancel out, and you are left with x equals 6. Yes, but of course, we can check it. 6 plus 5 is equal to 11, so 11 is equal to 11. That is a true statement. Let's do this a couple more times. First, we're going to take a look at each visual, and we're going to write an equation. Now, oftentimes, I will write pluses or minuses. For today, I think I'll use the red boxes. Oh, excuse me. So how do we get, okay, so what do we have on this side? We have some unknown amount, an extra $3, and it's equal to 1, 2, 3, 4, 5, 6, and 7. So how are we going to get rid of those 3? By adding a -3. But that's not fair, so let's go ahead and do the same thing to the right side. What will that look like with numbers and algebra? Adding a -3 to both sides. Naturally, 3 and -3 cancel out. You can see it with my algebra steps as well. Oh, and let's see. Okay, so we have x equals on the left side. What do we have on the right? 7 and a -3 do have some 0 pairs, leaving some positives left over to make 4. Circle your solution. Some of you got to build up that habit. Circle your solution, please. Let's go ahead and check. 4 and 3 do, in fact, make 7, which is a true statement. Remember, anybody can come up with some random number and call it their answer, but a solution is a number or numbers that makes a statement true. Any other number in the universe other than 4 would not work for this equation. All right, let's see over here. Go ahead and hit pause. Try to make your own equation for this, even if you're just thinking of it in your head. Come on back when you're ready. On the left side, I'm seeing 1, 2, 3, 4, 5, 6, 7, and 8. On the right side, I'm seeing x and an extra 6. All right, so how will we get rid of that extra 6? Well, to get rid of positive 6, let's go ahead and add a negative 6. I know some of you say subtract 6. Please remember that subtracting 6 is the same as adding the opposite of 6. Now let's go ahead and be fair to both sides. Add negative 6 to the other side as well. Now in this case, we will have some canceling out. Positive 6, negative 6, good. That is what we wanted. We only wanted to know what x was equal. And once again, we have positive 6 and negative 6 canceling out, making some 0 pairs. Aha, sure looks to be 2. With our algebra, positive 6 and a negative 6 make 0. 8 and negative 2, I don't know really why I turned that around. Sorry about that, but x is equal to 2. And in this case, if you were to substitute in 2, it will be a true statement. Now, let's go ahead and forget the visuals just for a little bit and go straight to the algebra. But I want you to notice in this first example, we have a subtraction. Now, subtracting 9 is the same as what? Adding a negative or adding the opposite. So that'll actually be pretty much my first step. So how do we get rid of a negative 9? You guessed it, by adding. And of course, we're going to be fair to both sides. Meanwhile, a negative 9 and a positive 9 make 0. Negative 2 and a positive 9, you are now above water with 7. Let's check it, make sure it works. You know me, I'm going to change subtraction to adding. What's the opposite of 9? Negative 9. So we have a positive 7 and a negative 9 make a negative 2. And that's a true statement. Speaking of changing to add the opposite, anytime I see this nonsense, I'm thinking to myself, well, wait a second, what does it mean to subtract a negative 5? Naturally, what I would do is change subtraction to adding, and the opposite of negative 5 is positive, and now it's really not that difficult from equations we've been doing for a long while. How do we get rid of a positive 5 with a negative? Some of you might just write subtracting 5, and I can respect that. I'm going to switch it to adding the opposite, because a 5 and a negative 5 make 0. Whoop, we got to be fair to both sides. And in this case, positive 22, negative 5 makes 17. To check it, little question mark up here, change subtraction to adding the opposite. 17 plus 5 is 22, and that appears to be a true statement. In other words, if your total goal, your objective, is to get the variable isolated by itself alone, the key thing here is to undo addition, focus on adding the opposite. Now, some people would say to undo addition, you can subtract, which is fine. But what have we been learning about subtracting integers? We changed subtracting integers to adding the opposite. I'm going to highly recommend for now to rewrite addition as adding the opposite. All right, I got 4 more examples. If you feel good, head into the homework. Meanwhile, I'm going to buzz through these. Actually, let me do the first 2 and let you see how you do with the next 2. So first off, we have an n plus a negative 3. How are we going to get rid of that negative 3? With a positive 3. And of course, we're going to be fair to both sides. Now, a negative 3 and a positive 3 cancel out, leaving us with our goal of n by itself and equaling. And in this case, 7 feet below water, 3 feet up, and we're still below water. But let's go ahead and check it by substituting in a negative 4. If I were to rewrite the original equation, I don't think n is unknown. I think n is known. So let's go ahead and substitute a negative 4. And in this case, -4, -3 makes a -7, which is a true statement. Off to number 2. How do I get rid of a plus 12? I know some of you are going to write subtract 12, but I'm really focusing a lot in the next couple weeks on adding the opposite. So myself, I'm going to go ahead and focus on adding the opposite. Meanwhile, let's be fair, add the opposite of 12 there. Now, -12, +12, those put together, cross off, they make 12 zero pairs. Adios, arrivederci, au revoir. Meanwhile, -3 and -12 makes -15, and it appears that we have our answer here. But let's check it. By rewriting the equation and substituting in for the unknown variable, we think we know what that is. We think it's -15. -15, +12 ends up still in the negatives, but taking away those zero pairs, we have a true statement. Video's getting a bit long, folks, so why don't you go ahead and do the next couple examples, pause, and come on back and watch me go through it quickly. I'm going to change -5 into adding the opposite. How do we get rid of a -5? By adding a positive. -16 plus 5. +5, -5 cancel out, leaving us with y equals -11, or does it? Rewriting our equation, but substituting in the -11. -11, subtract 5. Oh, you know what's coming. Mr. Cowan's going to go ahead and change that into adding the opposite. -11, -5 goes deeper in debt or deeper underwater, and this appears to be a true statement. Meanwhile, forget this nonsense. Why would we write subtract -5 when we can just change that to adding a positive? So how do we get rid of a +5? With a negative. And I'm going to add a -5 to both sides. In this case, +5, -5 cancel out. Good. Our objective was to get f by itself in alone. Meanwhile, 13 and a -5 still got $8. Rewriting the equation. But we think we know what f is. So let's go ahead and substitute in 8 and see if this in fact works. Meanwhile, I'm of course going to rewrite subtract a negative into adding a positive, adding the opposite. 8 and 5 is 13. We get a true statement. All right, folks, there's your homework, page 109, numbers 24 to 43. Do well and let's grow.